Hello everyone, thank you very much for joining me again for a new Java Fundamentals lesson. It's lesson number 31 from the Java Fundamentals stream, and we are starting the discussion about generic types. So I say we are starting the discussion about generic types because I expect that this will take us more than 1 hour, so it might be that we will have to continue the same subject in the next lessons. Let's see how much can we deal with today. Don't forget, if you are watching the event live, that you have a live chat there, so I'm always keeping an eye on the live chat. If you are sending questions, I will answer them. If you have questions after the video, maybe you see the video recorded on this channel and you have questions, you can send me the questions as always in the comment section below, or you can find me on LinkedIn or Twitter and you can send me the questions there as well, and I will answer you in a separate video or in the next lesson depending on your question. So let's go on with the today's subject, and I have already created here my Java project, and you know I'm using always the latest version, which at the moment is version 13. And because we are discussing about generic types, I will create a package in the source folder of my project, and then I will start with creating a class. I will tell you what generic types are, and then we will step by step all the needed syntaxes, all the things you need to know from the syntax point of view. That means for what you will use in practice, as well as what is requested for your OCP 11 certification exam. And of course we will also discuss as usual best practices, things you need to know for a real world scenario, but not necessarily that you will find in the certification. So let's get started with just a first example. I will call it example 1, and then inside this package that I have created, I will create a class foo, because I'm less inspired now. I don't know what name should I give to this class. Is just for presenting you the syntaxes you need for the moment. So what is basically a generic type, and where did this start from? Well, there are situations in which you need to have an attribute or a type inside the class. It can be a return type of a method, or it can be a parameter of the method, or even for the constructor. It can even be, in some situations, the return type of the parameters of a static block, like a static method. The thing is that you don't know from the beginning what type should this be. You only know, for example, when it's about behavior or an attribute, you know only when you create the instance. Or if it is about a static block, like a static method, you only know when you call the method. So how do you deal with such situations? Let's keep it easy and take it step by step. I will start with the part with the instance, which is very often encountered in developing classes and functionalities using generic types. So let's say in my case I only need an attribute. I need to define an attribute x, and I know in some cases this might be an integer, in other cases it might be a double, in other cases it might be a string. So how can I deal with this situation where I don't know what will be the type of my attribute until the moment I create the instance? You will say, of course, you can make it an object. So let's make it an object, and then you can assign any kind of value to this x now, because of course object is, as you already know, and as we have discussed in one of our previous lessons, the most upper class in the hierarchy tree of classes in Java. And that means that you can, by polymorphism means, assign any value. Anything is an object. So even a number, even an integer is an object. You can assign it to an object. So that would solve my problem. And of course, this was actually the case, and this was the only solution you could use until the generic types appeared, I think, in Java 4. So it was quite a long time ago. I don't think it's needed to discuss about the times when generics were not part of the language, but you must know that generics actually haven't been here for from the first version of the language. They were inserted in the language somewhere in version 4. And the reason for why we need generics is because we don't really like the fact that we have to use object in this case, because using object forces us then to do casting and conversion of the values inside the attribute. And then when you do casting and conversion, if you don't cast to the correct value, then at the runtime you will have an exception, and this exception is called the class cast exception. And for the beginning I will actually try to use object and prove you what's happening, and this way you will recall, because we have discussed about casts in one of the previous lessons, so you might remember that, and that's actually my purpose, to remind you about this. And then when I will apply the generic type, I will show you how this changes the syntax and how it moves errors that can appear at the runtime because of this casting to the compile time, which is better because compile time is always, of course, earlier than runtime. That means that you avoid sending this kind of situations to your customer. I don't know, you can't anymore create a version that contains this kind of problems, because you won't be able to compile the application if you don't respect the correct type. So that's one of the most important reasons for why we use generics. So again, to prove you that, let me just create an example one class where I will have the main method, and then here I will create a foo instance, and then I have an x here, and then I can assign a value to x. Let's say I can have a 5, and then I can have a second instance, and x can here have a string. And what happens now if I need to refer, oh sorry for that. So see exactly what I meant. It's actually I was already making a mistake here, assigning the wrong type to the wrong instance just because I can. So and that's exactly one of the things that can happen. So if you are not attentive, and it was right in my example, and it wasn't even planned. So that you can see, you can make this kind of errors even if you have plenty of experience. So now I have two instances, and I have assigned different values, and now assume that you use them somewhere in the application. So you do something, and at another point in your application you will basically have to use them with their value. So you would like to have something like int x is f1 x, and of course this is not possible because now it's x, which is an object, is a more generic more general type than the integer itself. So what you will actually have to do is a casting. So this is exactly what you want to avoid with generics, because when you do a casting like this, now assume that I use it in some other part of the application, I don't know, or I forget to which of the instances I have assigned a 5, and to which of the instances I have assigned a string. And the same way I can just change f1 to f2 here, and of course this will work from the compilation point of view because both of them contain objects. So an object can be a string and can be as well an integer, and can be anything else, can be a cat, can be a dog, can be whatever type you create in your application. And that will allow me to cast to any kind of a type, because whenever you go from up to down in your inheritance chain, you can do casting. So you can actually in Java cast whatever more abstract type to a more particular one. Always you can do that. The only compilation failure would be if you try to convert between two types which are in parallel on the hierarchy tree. But in our case, object is always upper than anything else, which means that we are always from up to down, which means that this conversion always works. So you can try any type here. You can try to convert x to an integer, you can try to convert x to a string, you can try to convert it to any kind of object, and this will work. but it will work from the compilation point of view, because if you don't use the correct type, like I am doing here, I'm trying to convert back this x of f2, which is this one here, and you can see I have assigned a string. Actually, when you will try to do the conversion between the string and an integer, the compiler doesn't complain because it doesn't know at this point. It only says an object can be an integer, but it doesn't check inside the variable itself. But when I will run it, I will have the class cast exception. And this kind of exceptions is what we want to avoid by making sure that we always say explicitly what kind of object we use. And it's a very important best practice to always say explicitly what your objects are. So instead of using object for storing any kind of an object, always refer to what exact type that object is, and you will avoid the class cast exception, like it happens in my case now. When I have run the application, I have expected this because I try to convert a string to an int. So how can we make sure that instead of having such kind of a trouble at the runtime, we move it at the compile time? Well, we use generic types because that's what we are discussing in this lesson. So here is where I will try to convert my implementation to specify what object do I have here. So because I don't know exactly what this object is from the beginning of describing my blueprint, remember the class is a blueprint, you describe the object through the class, but in our situation we don't know what type is X here from the beginning. We'll only find this when we create the instance, and the two different instances might have an attribute with different types. And this was the reason for why I have used object, knowing that object can retain any kind of value. But you've seen that the problem is now that if I use object, I can get into class cast exceptions. So how to avoid that? Well, we use generic types, which are types we define when creating the blueprint, and these types that we refer syntactically by identifiers between the symbols of greater than and smaller than. So this is the syntax, this is the way we are defining them. Usually we use only one capital letter for them, so they are normal identifiers, but by convention you will only use a capital letter. And this T now is a type that Java assumes you will provide when creating the instance. So I can use T for any kind of instance linked member of my class, which can be an attribute, which can be a method, which can be the parameter of the constructor, and then I can specify who is T when I create the instance. So to prove you that this is possible for all the members I have suggested, I will also create the constructor here, assuming that I want to obtain the value for X like this. Okay, so you see I may use this as the type of the parameter of the constructor. Just to have it, I will also create the constructor with no parameters, and then let's say I have a method called print X, and you will see that I can actually use X here. I can actually have it as a parameter if I want in a getter or a setter. So I can use actually this type T wherever I need it, as long as it is a member linked directly to the instance. So it's an instance member of a class, is not a static member. So in this case, the way I have defined the type T here, I cannot use it with a static type. So if you will try a static definition like static void something, then of course I won't be able to return T from here. So this is not possible. I wouldn't be able to receive T as a parameter here. This is not possible because T the way I have declared it here near the class is only for the instance related members of the class. So keep that in mind. You will see me using generic types with static blocks as well. This is possible. It's another kind of a syntax. I will discuss it later because I don't want to put everything on the plate from the beginning. Otherwise, anyway, generics is one of the most difficult subjects from the fundamentals. So I want to take them step by step, but keep in mind just that for now, when you declare it like this, you won't be able to use it with anything static. It's only for instance related members. So that's non-static members. So you can't use it with a static method as you've seen there, and you can't use it with a static variable as you see me doing here, and you can see is underlined with red. That means that my IntelliJ here tells me this is a wrong syntax, and this is true. It is a wrong syntax. You can't use T to declare static variables in the class the way I have used it now. If you want to think about the real reason you can't do this, it's pretty simple. When you declare T like this, it will only be known, as I've said in the beginning, when you create the instance. But remember, if you have something that is static, that static member is initialized before any instance exists. We did discuss this somewhere in one of the previous lessons where we said more about the garbage collector and the memory management. If you remember, we have also discussed initializing blocks, and you know that the steps for creating the class itself is first initializing the static members and then the instance members. So that means that if you know the type T when creating the instance is already too late for a static member. That means you can't use it for a static member because it should be already known, and it isn't at that time. So that's why for the moment we can use it the way we have declared it here, only with non-statics. And what I've done here, now I have a class that has an attribute I've called X here, and this T can be now provided with the instantiation. So I'm going back to example 1. Actually leave example 1 as it is, and I will go back to it a little bit later. I will create another class, example 2, and I will define as well my public static void main here, and I will show you now that I can specify when creating my instance that X is a string, and then I will only be able here to assign a string. So try to assign now a value of an integer. It won't work. By defining string here, it only allows you to allocate a string. The same you can do to declare an instance that only takes integers. So then you can assign an integer value and only an integer value and nothing else. And this way now, whenever somewhere in the application, because that was our initial scenario, you would like to take that X back, you can do that directly from F2 and say, okay, I want to assign back with the value from the attribute X to the local variable X. And can you see here I have no casting requested anymore? And even if I would like now to convert it from the string to the X, this won't even work, neither if I try to do a cast, because now string and integer are defined explicitly, and I know that they are in parallel on the inheritance hierarchy of classes, which means that the compiler won't allow me to do even a cast is not allowed here. And this basically helps me avoiding situations like you've seen in the first example where I was using object and then I could have converted the object to anything, and by that I could have done mistakes and receive these kind of exceptions at the runtime. So now I move these kind of exceptions at the compile time, which allows me see earlier and correct the problem earlier as well. Before going further and discussing more about the generic types, I would like to tell you, however, that these generic types don't change the bytecode, which means they are only a feature in the source code itself. In the end, when the bytecode is generated from the source code by our Java compiler, it will still be only an object there in the bytecode. So there is no generic type in the bytecode itself that only resumes to an object, and then if I do something like this, this still becomes only an object in the bytecode itself. So generic types only help us from the source code to the compilation to the bytecode to make sure that we don't do this kind of mistakes of casting and converting. So their purpose is up to the compilation. Then after the compilation, they anyway don't exist anymore. So they are not a feature that adds a lot of discussions about this kind of syntaxes. So if you look carefully, you will actually even see that the string here is in a gray that somehow tells me that I would actually be able to cut it out, and this is actually possible. This is called the diamond operator, and syntaxes like this we can use. They are a lot complex, and they can be used a lot with our in our applications. Now the problem is that we have to take them step by step, and for the moment I have defined them like this really just because I really want to tell you all the syntaxes step by step so that you understand them better. So let's now go a little bit back to example 1 because I have left it hanging there. So I want to explain a little bit more about this, and then we will again go back to discuss all the syntaxes we need for the generics. So what you observe here in example 1, which I didn't change, is the same example 1 I have written from the beginning of our lesson, is that the code still compiles the way it is. So isn't that funny? Isn't that making you ask questions that like, why shouldn't I now specify which is the type here? Like in my case, I changed the class itself to specify this T, and X is of type T. So how is that this code is still compiling even though I didn't specify who is T here? Well, this is because, again, going back to what we discussed earlier a little bit at the beginning, when Java came out with its first version, generics didn't exist. So when they were introduced in version 4, they were introduced such that they shouldn't affect, they should be backwards compatible with the previous versions. And one of the main reasons for that is because, as you will see in the next lessons, they are actually used pretty much with collections, and collections are one of the most used features of the language, and they were changed with generics as well at that time. So if if it wasn't possible to compile your application anymore without specifying the generics, then it would have forced the code the previous written code to be changed and then recompiled, and that lacking backwards compatibility would have been a great disadvantage for the language. So what actually happens is that when you specify something like this, and the reason for why this code still works is that when you don't provide the type of the generic, it will take, in this case, the type object. So it actually really works as in our first example. But even if it's possible, and maybe only for certification questions you need to know it's possible to have an instantiation of a class with generic types without specifying the generic type, you shouldn't use this in a real case scenario. So never use classes with generic types without providing the type for the generic type. You need to know that this is possible. Whenever you are going to that OCP 11 exam, you might get a lot of kind of questions. OCP exams test you for almost probably any kind of details of the language. But as I've also stated in previous lessons, not all of these syntaxes really need to be used in applications in real world scenarios. So this is one of the things that you should actually avoid to use in your real world scenarios and real applications you're working on. So always when you have a class with a generic type, provide a generic type. Never instantiate that without specifying who the generic type is. Otherwise you will get into the same situation as we had previous to having generic types in the language. So that's what I wanted to mention, and to show you that this is now possible, still possible, but you shouldn't get into that situation. So we always have to specify who is the type for that specific instance, and this way, as you have seen, I'm not allowed anymore to assign a different type, which is good. That's the purpose of the generic types. Now we have to discuss a lot of syntaxes, so hopefully you did understand the purpose of the generic types, and that they only exist in the source code and not in the bytecode, and the very simple first syntaxes of how to declare a generic type for a class and why it's possible to use it with non-static elements, members of the class only here. But we have now a lot of syntaxes to discuss in terms of declaring and creating instances. So you see me here on line 6, I have used the declaration of my generic type, and you can see that I have specified the type in on the left side of the assignment operator, and on the right side as well of the assignment operator. So you see I have twice used the type here. So is this the same thing actually? When I write it here, do I actually write the same thing twice, or are they different? They have a different meaning, and actually they do have a different meaning. So when you declare it on the left side here, this is a constraint, and we have 4 kinds of constraints that we apply to variables declared for types with generics, and we have to discuss them one by one and see when do they apply. When you have declared the type when defining the instance, so when calling the constructor together with the new operator, so in this case the type itself is actually exactly the type with which you that you specify for the t inside here. So in the left side here, it's not the type inside. You will see that what we specify here is just a constraint. On the right side is where we specify the type. So when we create the instance, this is exactly where we say who is t. So in my case, for this line, t is of type string. For this line, t is of type integer. By the way, I see some error in the live chat, so I might not see your questions. If you send them, I'm not sure if I'm receiving them or not, but hopefully I do. If you however find out that I'm not answering to your questions, then it's because I don't receive them. So you can leave them later in the comment section. I don't know, YouTube has some problems, and it happens with live events that we have problems sometimes. I only see an error message in the live chat here, so I might not receive your questions. Just for you to know, hopefully you know that I will answer your questions if you leave them in the comment section, but if I don't see them, I can't answer them, of course. Okay, sorry for that little pause. I will continue now with my explanations here. So I was telling you that this is different than this one. So in which way this is exactly where you specify who is t, and this is basically where you specify what are you allowed to assign to that variable. So that's the difference. And now we want to take them and understand this difference with the left side where we discuss the constraints, and then we will see which are the needed syntaxes you need to know for the right side where you specify the type itself. So let's go to a third example. I will create an example 3, and again I will create public static void main method, and I have a foo, I will say integer new foo, and maybe I don't even need for the moment to create the instance. I only want you to focus on the left side, so let me just write something like this. This is the first wildcard. This is any object wildcard. Then we have the third, which is the extends wildcard. Then we can say here an object we would like to be possible to be extended by the type we use. So I will use a class named number. Number is a class inherited by integer, double, and the classes, the wrapper classes from Java lang that define numbers, of course. So just for this moment, number is not important for my example. Important is just to remember that integer extends number and double extends number as well. So all three are actually classes from Java lang, and you might already know integer and double. They are wrapper classes. They treat primitives like objects. I'm not sure if we have discussed wrapper classes. If not, I will do that in a future lesson. But for the moment, for you, it's just important that this class extends this one, this class extends this one. We will use this information in understanding the wildcards. So in my case, I declare an F3 here which has this wildcard, and then I have the fourth constraint, and this presents also the last wildcard, the third wildcard, which is foo question mark super number, and I declare F4 here this way. Okay, this is good. So this is what I can use on the left side. That is the declaration of a variable of a type having generics. When I say that, is that I can use the type to declare a variable, a normal variable like a local one. I can use it to declare any kind of attribute or static variable. I can use it to declare any kind of parameter, and I can even use it to declare return types. So I can say something like this. See, so where do we use this kind of constraints? We use this kind of constraints where only when we refer to that type. It can be referring to that type to declare a variable, a parameter, or even the return type. This is all the time we refer to the type for this reason. What we use, even if we use a precise type like this, it is still just a constraint. And that's what I will try to explain you now. So a constraint, meaning actually which forces you, tells you what you are allowed to have as a generic type of the instance you provide there. So for example, for f1, if I try here to create an instance, the only type I can use for this instance now is integer. If I would try to assign any other kind of type, any other kind of generic type for my instance here, it won't be possible and it will generate a compilation problem. So if I, for example, try to make this a double, it creates a compilation problem. If I try to make it a string, it's still a compilation problem. The only thing that I can use is integer itself. So this constraint where I specify the precise type I can use only allows me to use that type. Be very careful, this doesn't even work with inheritance. So if I declare an instance using the type number, I will call it f5. Again, f5 can only receive an instance, the reference to an instance having a number here. And even if I know that integer extends number, it's still not possible to use integer if you will try to put an integer here or any class that is a child of number, it won't work. When you use this constraint that defines the precise type, it is only the precise type you can use on the right side. That means when you use it on the instance of which reference you assign it to the variable. So here I can have number, but I can't have anything else. Neither even a class that extends number. Even if you know that in general this would work with, for example, variables, and that's the first thing. It might create confusion in the beginning when you see something like this, is because you know that when you have this kind of situation, by polymorphism, Java allows you to store the references of objects in shapes defined by the classes which represent their parents. So for example, if I write something like this is possible. I can put an integer in a number. I use this constructor even if it's deprecated to show you that this is an integer. Otherwise I should have directly have written the number here. That I want to show you that it is an integer and the syntax works correctly. I have no compilation problem when I do assign an integer to a number, because integer indeed inherits number. You can go in the integer class and you can see that directly in the class. Somewhere here it says integer extends number. So that's the reason why by polymorphism you can assign a value of integer into a variable of type number. But when discussing about the constraints on generic types, when you use this constraint, this doesn't work neither with children classes. So when you do specify a precise type in generics, this means the value of the type of the instance should be precisely that one, not a superclass and not a child of any child of that class. It won't work. It works only with that precise class. If you do want to have the possibility to use the children as well, then you have this constraint I have declared here. I have used here to declare f3. So when you use this kind of constraint where you specify this wildcard question mark and you say question mark extends number, that basically means in f3 you can have any instance of foo having as a generic type either number or any of the subclasses of number, so anything that extends number, and only this constraint will work with the type itself and also its subclasses. And you can test this. You can see that when I use the foo here, I can assign to f3 a foo having the type number as generic, but I can also assign to f3 a foo having an integer, which we have seen is extending number, and any other class like double is also extending from number. But it's not possible to have something that is either above number or not extending number. So for example, I won't be able to use string. So if I try to use string, then this is a compilation problem. So I have a compilation problem because string doesn't extend number. Okay. So remember the very big difference between having the precise type and having extends. When you have the precise type, you can only use that precise type. If you want to be able to use children, you will use extends. In general, don't forget that we are always going to the most powerful constraint possible when we use generics. So if possible and we can define precisely the type, we go and define precisely the type. So we go from the constraint that is the most powerful to the least powerful, but we prefer always to go more powerful than least powerful. That's the best practice of using this in generics. And yes, we've discussed about this one, and we've discussed about this one as well. And now I will go to this one because it's pretty easy. So you see, if I have an extends, then I can use the class and its children. Then if I have a super, I can use the class and its parents. So in my case, f4 means the class and its parents. So that means that f4 I can use number, and the parents of number, in my case, I know for sure at least object should be a parent of number. So object, and it's working, but I cannot use any other class. That is, I cannot use children of number like integer shouldn't work here, or string, that is neither a children neither a superclass. So this is compilation problem. Okay, and then I have the last one we need to discuss, which is just question mark. And I think you guessed, question mark means you can use any possible type, anything you want. So f2 in my case can receive instances with string, with number, with integer, with object, with whatever you want. So f2 can be object, it can be number, it can be integer, it can be any kind of class you would like to be. So you can have anything here. Question mark means no restriction. Now a little bit more details about this, because we didn't finish. So we still have a lot of things to discuss only on these constraints, and we didn't get neither to the first third of our subject, the generic types. So I think we will need more than even a couple of lessons to discuss everything, but that's good. We will do that in the future lessons, so no worries. I will cover all the subject as I'm doing with any other subject we discuss. So first of all, the first confusion I see with starting working with generics is the confusion between having declared a variable with foo object versus foo question mark. So is here any difference between declaring a variable foo with object versus using foo with question mark? If you were attentive to what we discussed earlier, you've seen that we've started with using the constraint with the declared type, and when we've done so, you've seen that you cannot use a subclass. So that basically means that when you use foo with object to declare an object, then on the right side, that in the instance, you can only have object here. If I would try to use number or string or integer or any kind of object, this doesn't work, because when you specify the precise type on the constraint, it's only that precise type that you can have here. While if I were to declare with the question mark constraint, that really allows me to have not only object here, I can have basically anything. So with a question mark, I can have number here. With object, I can only have object. If I try to put something else, it doesn't work, because remember, the constraints on generics don't allow polymorphism. To have polymorphism, you need to write something like question mark extends object, for example, and then if you do something like this, it will work, because question mark extends something means that something and all its children. But when you have only that something, it's only that something that you are allowed to have here. So that's the first confusion I almost always see when somebody starts with generics, the difference between foo of object and foo of question mark. And I've also seen that plenty of times in the OCP 11 questions. So be very careful you remember the difference between these two. So this is one of them. The second thing refers to what you can do with these values, but because I have already filled a lot of things here and explained a lot of things, I will move to a class example 4 to make it a little bit cleaner. So allow me to write an example 4 for this, and you will actually see that these constraints really apply you constraints also on how to work with the value put inside. So that is really important, because if you do use the constraint in which you specify the type directly, like integer in my case here, let's assume I declare something like this, then you will be able to change the value of x. So you can make it 10 and then you can make it 20. It's just working like a normal variable. You can work with it. The only thing that you know is that the type was defined here. Oh, sorry, for the moment I would like to avoid using this operator until I tell you what's about, so I will put it here for you to be clear. So that is, if I specify here at creating the instance who is x in terms of type, then I can just use it as a normal variable. But this is not the case when you use the wildcards. So for example, if I use the syntax with number, and I will start first by using the syntax where I specified the direct type number here, then of course this will act exactly as the F1 above. So F2 x is 10 will work perfectly, because I do assign an integer to a number, which by polymorphism is correct. Integer being a number, that's fine. And I have used the directly specified type constraint on my generics here, so I can change the value of the variable. Now, you know from the third example we've just finished discussing that I'm not allowed now to, for example, use here integer, even if I know that integer extends from number, because this is how generics work. So in this case, from this point of view, I cannot use the same as I do with polymorphism. I have to use a precisely different constraint where I specified that I want to have number, but as well any of the children of the class. so everything that extends number, and then I can use integer, and you see that this line compiles. But what you also observe when I have changed the wildcard is that the line with the assignment doesn't compile anymore. And this is precisely how Java works when you use the extends wildcard. So actually it works this way if you use either the extends wildcard, either the any wildcard like this. In both situations, you won't be able to change the value of the variable referred by the generic type anymore. So it simply becomes like a constant from the compilation point of view. The compiler won't allow you anymore to change its value when you use this kind of constraint through this shape. So through the type represented with this kind of wildcards of generics, you can't change anymore this value. This is important to know from the point of view of using generics in real life scenarios, as well as for your OCP 11 exam certification questions. You will find plenty of questions from the generic chapters, from the generic types chapter, referring to this rule of the language. So when you use either question mark extend something, or you use just a question mark, then you cannot change the value of that variable anymore. So that's important to remember. So I will put it in a comment and I say doesn't compile. Okay, but I can change the value of the variable if I use the direct type or I use the super type. So I will say, for example, question mark super number f3, and then here I can have number, or I can have object, or I can have, when I specify just in general, we can say we can have any parent, that class, and any of its parents. When you would do something like this, you can still change its value. Why can you change the value for this one and for this one, but you cannot for the others too? Well, if you look carefully here, you will see that in this case, this is the easiest. Of course, you can change its value because the compiler knows precisely which is its value, because you can't have another value here. So it's basically this constrains you to a specific type, and then you are allowed to change that type because the compiler knows what the type is. And in this case, with a super, you also know what the type is, or you know at least it's a parent of that type. But knowing that is that type or a parent always allow you through polymorphism. Remember, what can we have here? We can have a number. Can you assign a number to a number? Yes, you can assign a number to a number. What else can we have here? We might have an object or any parent of the number. Can we assign anything that's a number to a parent of the number? Yes, we can assign anything that's a number to a parent of the number. The compiler doesn't have any issue, doesn't have any situation where it's not sure for it if we are or not allowed to assign that value. And because there is no issue, because there will always be possible to assign a number to a number or to anything that's a parent of the number, because of the polymorphism in Java, then it allows you to do the change. But if you go here with the extends or with the simple wildcard, here is where the compiler cannot know for sure if the value corresponds to what you have here. So you see here, I can have question mark extends number, and then my instance, actually it might be of integer, but the number might also be a double. So the compiler doesn't know if x here at this moment in time is an integer or is a double or is any other kind of type which is a children of number. So that means the compiler at this line isn't precisely sure of the type of X. And because of that, isn't precisely sure if a cast isn't required. And because generic types don't allow casts, or actually we can say they were created, they were meant to allow us avoid doing casts and conversions, then for these two kind of constraints applied, you won't be allowed to change the value just because the compiler is not sure about the value itself. So this is the subject with which I will end this lesson. We had some issues during the streaming. I have seen some errors from YouTube. I'm not sure how well did it go. Hopefully it did go well. I see a lot of you are still online. Again, most probably I didn't see your questions in the live chat. I still have an error on my live chat here. If you sent a question and most probably I didn't receive it, please just let me the question in the comment section and I will answer it in the next lesson, because in the next lesson we still continue with the generic types. Anyway, remember that you can ask questions anytime in the comment section whenever you see the video recorded, or you can find me on LinkedIn or Twitter as well, and we can you can send me questions there as well. Thank you very much for joining me today. I hope you enjoyed this first part of generic types, and we will continue with the generic types in the next lesson as well. And until then, I wish you a great time for study. Thank you very much.